Hello, my name is Rio, and today I'm going over my week 12 summary. For this week, one class was canceled due to unpredicament circumstances. So we were assigned an online so we were assigned to go over our materials ourselves. That's why the class hour is cut in half, like the usual weeks. So let's begin. So for this week, we actually went over circuit analysis. We went over circuits, mainly RC, RL, RC, RCL circuits, and how we are able to transform them using DFQ techniques. So the first, we also talked about filters and what they are and how they are used. So let's take a look at the circuit analysis. So for the first circuits, we actually look over the RL circuits. As you can see, it's basically in one go. It's according to Kirchhoff's law of voltage, KLV. There's going to be a voltage drop at the resistor. There's going to be a voltage drop at the inductor. So their total should be the amount of voltage being inputted. We are able to then actually rewrite this equation over to here, which then we can use our DFQ skills to actually solve it to get rid of not to get rid of to dismember the differential slope. We can solve for k since we know that initially when the time equals 0, we know that the current should equal 0, giving us this equation which we can actually rewrite it so that way it's this. The process is long, so I won't go over it. For the second RC circuits, we actually applied we use first order because it's the same rule. We're looking at the voltage drop at the resistor, the voltage drop at the capacitor. We know that the current's constantly changing, thus we can rewrite it as so. We can find the differential equation giving us this, thus this, and we can apply the first order differential equation of multiplication to simplify it, giving us a value such as giving us this value. And since, well, we can apply the same rules for k since last time, when t equals 0, I should equal 0. Henceforth, we know that the value of k is voltage over R, giving us this issue, us knowing what the current system should be. Now, finally, for the CL circuits, this is a tongue twister because we are not only doing with because we're not doing with inductors and capacitors one at a time. We are actually solving them at once. So for this one, we actually apply KLV, and thus giving us we can apply the second order linear homogeneous equation, resulting in possible values of what the current formula could be. So now we actually have three possibilities because of the rule of saying what's under the square root. Rather, it could be positive, rather it could be negative, or it could equal 0 under circumstances, or what are depending on what the resistance, the inductance, and the capacitance is. So here are the three scenarios of when it's overdamped, critical damp, or underdamped. However, by the end of it, they're all going to conjoin or forever be approaching 0. And each one will result in a different circuit, different formula for current. Oof. So let's go over let's just talk about filters right now, though. So filters or electronic filters are circuits which perform signal processing functions, specifically to remove unwanted frequencies components from the signal, or to enhance wanted ones, or both. There are a total of 3 different types of filters that I can say. Low pass filters, they usually consist of a capacitor and resistor, They're basically, if we set it up so if anything is higher than the max set, it'll be rejected, allowing anything below that frequency in to be played. High pass filters, though, they can be used same setup but reverse. We can set a frequency where if anything lower below that will be rejected, anything higher than that will be accepted. For bandpass filters, it's within, we set up a max and a min range where anything above the max will be rejected, and anything below the min will be rejected too. It's usually tends to be a combination of the low pass and high pass filters. However, you can also do both of these in different ways, such as we can use, for bandpass filters, we can use a RCL circuit. For a high pass filter, we can use a RRL, and for a low pass, we can use RC. Let's proceed. So this is actually a crossover network, which is a crossover network is a network that filters and diverts signals to different sections of the circuits. So it sends the low frequencies to the woofer speaker. It sends mid-range frequencies to the mid-range speakers, and it sends high frequencies to the tweeter speakers. These are usually set up within speakers to give it the round sound effect. All around you. As you can see from the setup, we're actually getting, this is the low frequency. This is like the mid-range, and this is the higher of the frequencies. It's hard to tell. I should include zoom-ins, but the units actually, although they all look the same height, the units actually increase if you go down the side. So here we actually have the smaller frequencies, which makes this the low bass filter, the high bass, and the band filters. So that has been my week 12 summary. Hope you enjoy. Have a good day.